Okay, we'll go ahead and get started. So, hi, folks. My name is Kat Gaines. I am a DevOps advocate at PagerDuty. And just a little bit about me. So, I'm a DevOps advocate at PagerDuty. You can find me at Twitter at strawberryfield with the I replaced with the number 1 as shown here. That's a great way to get in touch with me and a great way to chat if you have thoughts or questions about any of the topics we cover today after the fact. But you can also go ahead and enter Q&A if you'd like during the talk in the chat. I have a colleague from PagerDuty here with me who's going to help us with any questions that come up during that time. And we should have plenty of time for questions at the end. You may even get a little bit of time back from what you planned. I don't know that we're going to take the entire time allotted for this conversation today. So, the basics. We are talking about improving automation and reducing toil. So the first thing we want to cover there is what actually is automation? What does that word mean? You've heard the word, but have you really thought about what it means specifically? So when we talk about automation, it means we're going to take some manual processes that someone on our team previously had to run piece by piece, and we're going to ask some kind of machine to instead do that work for us. We're going to look for tasks that machines can do very well, that don't require a lot of nuance, creativity, or lateral thinking, and we're going to encode them so that the machine understands how to manage them. Then our humans are going to go do something more fun, more interesting, and at the end of the day, more valuable for what they expect to be doing in their day-to-day. Automation is really a key component in the management of complex real-time IT systems. The amount of information that must be processed and taken into account when making decisions or making changes is immense when you think about it. Microservices, cloud platforms, third-party and internally developed services all have their own little idiosyncrasies and behaviors, and there's just so much stuff that one person can't hope to know all of the things about all of the things. So to get work done and to do it right, teams need to rely on automation for their common tasks. Automation helps your teams avoid mistakes, increase reliability, increase repeatability, and reduce toil in their day-to-day work. We can use automation to build, test, and deploy software. We can automate the creating and maintaining of infrastructure components. Anytime we have to perform a task more than once or more than one person needs to be able to perform the same task exactly the same way, we should probably consider automating it to ensure that those tasks are completed as expected. Our team members aren't automations, so when we want to make sure processes are always performed the exact same way, what do? We automate. Automation can also take different forms. It might be a library of scripts and tools. It might be a set of YAML files that are ingested by a tool. It might be encoded in the configurations or a build server. These are all things that collect knowledge from your colleagues and store them in a place where everyone can use all of the amassed knowledge of the entire team. So we talked about what automation is. Let's talk about what toil is. Toil is really a 4-letter word. Our teams want to do interesting things, tasks that impact the bottom line, create value, and require some expertise and creativity. Toil is really the opposite of that. In general, toil is the kind of repetitive, tactical work that increases linearly as the size of an environment increases. So when we think about toil, we're talking about things like deploying updates to software and systems, adding user or system accounts, scaling environments, testing backups. The larger your environment, the more of your time these toil tasks take up. Even in fully modern systems, the task of regularly rebuilding short-lived environments to new versions is toil. Well, the problem is we know all this work has to be done. It doesn't particularly add value to the customer or the end user, but leaving it neglected will definitely impact the user experience at some point, sooner or later. It might allow a security breach. It might cause degraded performance. It's hygiene, just like brushing your teeth. Skip a day, that's kind of gross. Quit completely, people are definitely going to notice, and they're going to maybe be a little bit concerned for you. So while these tasks have to be completed, they don't have to be performed by humans every single time. They should be automated. Let's look at 4 drivers of automation in modern IT systems: complexity, speed, curbing mistakes, and reducing toil. Modern IT ecosystems might be composed of hundreds or even thousands of individual components. You have cloud infrastructure like containers, hosts, networks. You might have services for monitoring, collecting metrics, alerting systems like PagerDuty, log collection. You might have authentication and authorization or A/B testing or beta testing for new features. So you might have storage, runtimes for any number of different programming languages and frameworks. The number of possible combinations is nearly infinite. So when we have all of these different components, any of them can change at any time. Third-party services and resources get changed by the vendor on their own schedule, requiring updates and changes for our services too. It's really hard to keep up with where all the things are and what they're supposed to be doing, even for teams that are conscientious about their documentation. My list of service instances might be outdated before I finish it, especially if my environment uses sophisticated auto-scaling. Any work that I need to perform on the instances needs the most recent data, and so should probably be some kind of query to an API instead of, for example, a hard-coded list of instances. It's really easy to make mistakes using manual processes, especially those with many steps or with complex commands. One thing automation does for manual processes is that it allows your team to permanently record their expertise. You're taking all of the esoteric information folks have learned over their careers and putting the best practices in a shared place for use later, even when they're not around. Your team might have started some documentation in a runbook or wiki with multiple steps that need to be copied and pasted into a terminal. Even this task can have multiple places where mistakes are possible when people are stressed out or responding to a critical incident or just busy and distracted. They might copy things out of order. They might miss a step in the list. They might not copy the entire command if it's very long and scrolls off the page, or they might paste something into the wrong terminal. They could even have the wrong target systems or number of user accounts. Really, any number of things can go wrong. So finally, we automate to avoid toil. That repetitive work that we were just talking about that has to be done but isn't particularly interesting or challenging, patching hundreds of systems for a security fix, restarting services to incorporate a new configuration setting, granting access to new users. A team still has to know how to do all of these things in order to automate them, but performing the same tasks over and over again is not the best use of their time. Talking about automation can really invigorate teams, or it can sometimes do the opposite and instill a sense of dread. So we can talk a little bit about some of the concerns that your team might have when you're talking about applying more automation to your work. So one interesting myth that we've heard about automation is that, isn't it possible to just automate someone out of a job? Potentially and technically, yes, but really what you should be doing is automating them into a new job, a better job, a job that is worth more to your organization, making sure that their career continues to be about growth, and that is one way to do this. When your team has automated the toil out of their everyday tasks, they're left with the work that requires more creativity. Might be a little bit more fun to do. They have more room for feature work. They have more time for innovation. They have more time for even long-term planning, the thing that often gets pushed aside for the here and now of the toil task. Work that provides more strategic value to the organization can fit in here as well. These tasks are exciting to a lot of folks for a lot of reasons. They create new opportunities, they attract attention within the organization, and they promote career growth that just like I mentioned a moment ago, in ways that those more toil-based tasks just won't. When you're launching an automation-focused program in a large organization, it's important to be cognizant of the kinds of concerns your efforts might raise with your team. There will be folks who will see some of that toil as their job security or as the thing that they own. As a leader in your organization, you need to have a plan for those who are reluctant. At some point, their day-to-day job is going to look significantly different from what it once was. Instead of running manual processes, folks will be maintaining and updating those processes periodically and performing more high-value tasks on a daily basis. This cartoon here is a bit tongue-in-cheek. You definitely don't want your team to be spending all of their time maintaining, refactoring, and fooling around with the automation, but you will want them to have some time to devote to the basic maintenance. Automation is very rarely write once, run forever. Another myth that you might hear is that you don't have to know anything if it's all automated. This is a tough one. There is research in systems engineering and automation engineering that indicates having fully automated environments can hinder the skill development of junior engineers or new team members, but there's a balance. To create really useful automation, someone on the team has to have had, at some point, really robust expertise in the systems and processes being automated. Your team won't be successful if no one knows what is really going on, even with automation. Automation is part of the lifecycle of an application and the systems it is part of. It will need to change as the services change. It will probably need to be updated when the operating system or dependencies are updated. Maintaining the automation tools for a service is part of maintaining the service itself. So, learning how to maintain and test the automation, runbooks, or other tools for your services is a key way to help your new team members learn about the services. Does the start-stop script need to be updated for a new option? Are logs now going to a different location? Are updates now being downloaded from a different artifact repository? These are key pieces of system information that your team will use to maintain the scripts and tools that help you run your systems. Not only will everyone on your team still need to know things, they'll have to be very, very good at them. So let's look a little bit at what constitutes good automation, what that means. There are a wide variety of tools and platforms available to help you automate your workflows. It's hard to know what tools might work best in your environment. As a baseline, this list of requirements can help you choose tools that will help you automate and maintain the automation over the lifetime of your projects. This list is taken from Lee Atchison's book, Architecting for Scale, published by O'Reilly. If this looks like some of the same goals you might apply to software development, that's not far off. Whether you're writing automation yourself or buying tools to help you automate, you'll want to keep these goals in mind. Or if there are more things that are in your team's requirements or different lists that work for you, these can also just be examples. Just having a solid set of goals and having this thought through ahead of time is helpful here. One thing is that you want to be able to test your automation. It's going to be out there in your ecosystem doing things on your behalf, so you need to make sure it's correct. That might mean things like applying TDD methods to your automation code to help you and relying on your test suite when making changes and upgrades. Your automation should also be flexible so you get value out of it over time. You don't want to rely on hard-coded system lists or other data when you can add a database query. Variables for version numbers and service names will help you for upgrades. You'll want to put your automation in your version control systems and practice code reviews to help you maintain the automation over time. This is far better than having a directory full of files for folks to wade through when they have questions. And code reviews, along with your test suites, will help you manage assumptions and catch issues before they become production problems. This will also help new team members become familiar with the services and with the automation. You'll want to also keep your automation for related systems the same. This can easily get out of hand if your application teams aren't required to use the same runtimes or other tools. I totally get that, but anywhere that you're able to, reuse at least the components. Create official libraries and methods for dealing with your most common components. Make these solutions the easiest way to get work done so folks aren't tempted to create something else just to skirt around the rules. And then finally, we want repeatability and auditability. We want to know that every time the tool runs, it's going to produce a predictable outcome. Some tools are far better at this than others and provide easier tracking for who made a change or ran a command. Let's talk a little bit about idempotency. Hopefully you've heard this term before when thinking about automation and automation products, but if not, don't worry, let's review. Idempotency has a fancy mathematical definition, which says it is the property of certain operations whereby they can be applied multiple times without changing the result beyond the initial application. That sounds confusing and potentially ominous, but it's super helpful actually for thinking about what happens when you run automation more than once and how to handle any messages that might generate. For example, what happens on your systems when you want to add a user, but that account is already present? What happens if you want to rotate logs, but they're already rotated? Does your log rotation then create empty files? Does it do something else? If you are installing a software package that's already installed, what happens? What if you're concatenating a new configuration line to the bottom of a file, creating a new file, deleting a file? For the tasks you want to automate, you'll not have a human there to read the output and say, oh, this has already been done. So you'll need to add some kind of check to your automation to determine if the change needs to be made in the first place, and then maybe another check to make sure it was changed. This is where automation starts to get complex. You don't want your scripts to bomb out and return an error if the work they're trying to accomplish has already been completed, and you also want to be sure that the work is done. Some system tools will already have some idempotency built in, so they won't try to redo work that is already done and won't produce an error. Other tools you'll want to verify. They might not redo the work, but they'll return an error code, which will give you a false negative to report to the requester. If you're building your own tools, like using shell scripts, for example, you'll likely need to just build this in yourself. Automating the tasks that you do most often, or those that take the most time, will save you the most effort over the long term, as well as reduce your overall toil. Also, things that have the most complex or convoluted workflows, so you'll reduce the chance of a mistake. You'll also want to look at how comfortable people will be with having the process automated. Some tasks are going to be much more complicated to automate than others, so you'll want to consider that as well. There is always an applicable XKCD comic, isn't there? You might have seen this one. This table represents how much time over the course of 5 years you'll save if you automate a given task based on how often you do it and how much time you shave off the process. Making small improvements in tasks you do often will reap significant rewards. This also counts for activities that other teams are requesting, say via a ticketing system. If there is a way for the requester to do the job themselves safely without additional privileges or rights, that's going to save time for not just one, but now 2 teams, the team making the request and the team that would have to then fulfill the request. So what sorts of things should you automate? There's a huge opportunity in a lot of workflows to atomize tasks into their constituent parts and investigate the feasibility of automating those processes. This graph, for example, shows some example tasks that can potentially be automated and places them on 2 axes, impact and complexity. We made a list of the types of tasks that help in incident response, since that's a big part of what PagerDuty does. You might have similar tasks that you have to do all the time or a completely different list. But if you're struggling with what things should be automated, you can make a list of tasks you perform and put them on a graph like this. The impact graph compares how likely a task is to break something or have negative consequences in a production environment. Low impact things gather information rather than changing anything in the environment. Gathering information, fetching logs, doing a performance check, and running basic diagnostics. Tasks with higher impact are things like restarting services, whether a single service group or multiple services, or performing a failover. The highest impact tasks change key pieces of the infrastructure: firewalls, databases, rollbacks, or redeploys of software versions. These tasks can often have a higher likelihood of causing customer impacting issues if they go wrong. Then along the x-axis, we have the complexity, from the simplest things to the most complex or sophisticated. Simple restarts and information gathering are easy and likely only a single command. Fetching logs, failing over, making changes to databases are more complicated and might require some coordination between nodes. Multi-service restarts, capacity scaling requires more coordination and may require a configuration update to remaining services to let them know that peers are leaving a cluster. How comfortable your team is with any of these tasks being automated will vary. You might have some services that are actually more complicated to restart and should be moved to the right. Services that recompile code or load a lot of libraries into memory or can't do a cold start, that take a long time to be ready for activity, might have a higher impact if they need to be restarted, need approval, or need you to alert other teams. You could plot this kind of chart for any number of your common tasks with your team to figure out which things to tackle automating first. Where's the priority? Then we can look at how automation evolves over time. As your team gets more comfortable with specific types of automation, and as you get better at creating it, human interaction decreases and the automation runs more on its own. Automation opportunities is a fancy way of saying things we haven't automated yet. What tasks exist in your environment that could be automated but haven't? Human-initiated automation is our common scripts, our other tools that team members can run on demand when they want something done or need to complete a task in an unscheduled manner. Automation with oversight is automation that starts running on its own in response to some environmental trigger. This might be simple things like cron jobs that rotate logs, or more interesting things like restarting a service when it stops responding to queries. This automation still requires some humans making sure it runs okay. So while it might start on its own, it might alert a team member during its process to verify that everything has gone well. In the automation with fallback stage, the automation runs and only requires human intervention if something goes wrong. The automation might have its own escalation functionality to let humans know that it wasn't able to fix a thing, but if all goes well, the automation doesn't necessarily need to report. You'll see a significant reduction in toil at this point. Eventually, you get to the monitor and evaluate phase. Tasks get done with automation, edge cases are managed, and instead of tasks creating tickets or alerts, they might create metrics. Rather than Brian and April cleared N requests for X this week, you might see X was completed N times this week by the automation. This is the phase where your team is gaining the most from the automation when the tasks are completely handled and can be managed as a metric. Not all of your automation tasks will reach all of these phases. Some more complex tasks might only ever get to automation with fallback due to the nature of complex systems. Many organizations also have pockets of automation, but this automation is not available to everyone who might need it. The reason for this is something that we call the automation gap. Uneven distribution of knowledge means that digital infrastructure is so complex, nobody can know about all of the things, so we specialize. Uneven distribution of skills might mean that not everyone knows networking, databases, software development, or even just how to create automation. Uneven distribution of access means that in a secure environment, this is by design. Not everyone should have super user access to absolutely every system, or chaos may break out. What happens in these suboptimal environments, though? Folks are constrained and work is delayed waiting for someone else. People are forced to escalate to experts and specialists just to have them run the same simple tasks over and over when automation isn't shared. So really thinking about how your automation is shared and how it's available to the different users that need it is something you want to consider. So that is it for our talk. We would love to tell you more. We would love to share demos with you. We have some information on the slide about our Twitch channels, some links out to different resources on the PagerDuty website. And we'd love to even hear about how your teams are approaching automation, the benefits you're seeing. So feel free to reach out to us. Again, feel free to reach out via my Twitter account. Feel free to reach out to PagerDuty through our various channels and let us know how you're approaching and thinking about automation. Thank you very much.